Bismillahirrahmanirrahim. Dear student, Assalamu alaikum. Today we discuss the topic equilibrium constant. What is equilibrium constant? It is a number that expresses the relationship between the amount of product and reactant present at the equilibrium in reversible chemical reaction. How can we get this value of equilibrium? We can find out the value of equilibrium by finding the values of equilibrium constant when we calculate it if we have a concentration of reactant and product in equilibrium mixture. For that purpose, we express the chemical equation in terms of equilibrium expression. Equilibrium expression is the concentration of reactant over the concentration of product when chemical reaction reaches to equilibrium. Means it is the concentration of product over the concentration of reactant. Now, how can we represent this equilibrium constant expression for a general chemical reaction? Consider a general chemical equation. If A react with B, it produces C and D. A and B are the reactant. C and D are the product. Now, according to the equilibrium constant expression definition, it is the concentration of product over the concentration of reactant in a reversible chemical reaction. So, when we express this chemical equation in terms of equilibrium constant expression, then molar concentration of the product raised to the coefficient 2 the product concentration of the reactant raised to the power of their coefficient. These coefficients are the numbers that are used in equation to balance the chemical equation. And the square brackets show the concentration of the reactants in terms of mole per decimeter cube. Equilibrium constant may be Kc when it is in terms of mole per decimeter cube concentration, or it may be in the form of Kb when we discuss it with respect to the pressure. Here we discuss equilibrium constant expression in terms of concentration. Now, equilibrium constant expression, it is the product of a product concentration to the product concentration of the reactant substances raised to the power of their coefficient. Now, what are the units of Kc? For the unit of Kc, there are two cases. Case number 1. If the amount of reactant is equal to the amount of product. Case number 2. If the amount of reactant is not equal to amount of product. Generally, Kc has no unit because it is the ratio of product to the reactant. However, this unit of Kc depend upon the reaction. Now, we discuss these cases with the help of example. First, we take the balanced chemical equation. Hydrogen molecule react with iodine. In the reversible chemical reaction, it produces hydrogen iodide. 2 is the coefficient that balances this chemical equation. If you put this in equilibrium constant expression, we should write it with 2 molar concentration, Kc, molar concentration of hydrogen iodide raised to the power coefficient to the molar concentration of the reactant substances. These two have no power because there are 2 atoms of hydrogen, so 2 atoms of hydrogen, 2 atoms of iodine, 2 atoms of iodine. So this equation is balanced and this reactant side has no coefficient, whereas product has a 2 coefficient. Now, in terms of molar concentration, it is mole per decimeter cube square bracket mole decimeter cube and mole decimeter cube equal to 2 for both, or we also write it as a mole decimeter cube or mole decimeter cube. So these two cancel each other and it is equal to 1. It means it has no unit. So for a balanced chemical equation, Kc has no unit. Now case number 2, if the equation is not balanced. In this chemical equation, for example, N2O4 in a reversible chemical reaction produce 2NO2. In this reaction, the number of moles of product, as you see, is greater than the number of moles of reactant. In equilibrium constant expression, Kc NO2 raised to the power of their coefficient into N2O4. If you put their concentration, mole per decimeter cube square into mole per decimeter cube, then this one cancel, only one of them and one is left, that is mole decimeter cube. So this is the unit for this chemical reaction when the amount of product is greater than the amount of reactant. Similarly, Kc has a unit for the reaction in which the number of moles of product is less than the reactant in a balanced chemical equation. For example, when nitrogen react with hydrogen molecule in a reversible chemical reaction, it produces ammonia. Now we balance this chemical equation, then we put 3. 2 atoms of nitrogen, 2 atoms of nitrogen, 6 atoms of hydrogen, 6 atoms of hydrogen. Now you see that there are 2 moles of ammonia are present, whereas there are 4 moles, total 4 number of moles are present at the reactant side. So at this time, the concentration of a reactant is more than the concentration of product. Now what happened in this case? If we put it in equilibrium constant expression, NH3, 2, nitrogen, as it has no coefficient, H2, it has 3 coefficient. Now, according to Kc, mole per decimeter cube, mole per decimeter cube, mole per decimeter cube 3, or we can write it as a mole per decimeter cube, mole per decimeter cube 4 times. Now 2 ones are 2, 2 twos are 4. So in this chemical reaction, the unit of Kc is 1 by 2. So in this case, if we move forward the 2 in upper direction to the product side, then it becomes Kc, this 2 multiply with this mole per decimeter cube, then mole per decimeter cube, this 2 goes to minus 2. Now this Kc is equal to mole per decimeter cube minus 2 multiply with this, then it becomes mole minus 2 minus 3, it becomes plus 6. So this is the unit for this chemical equation. So for equilibrium, the unit for equilibrium constant, we have 3 cases. If the equation is balanced, then it has no unit. If the concentration of product is greater than the reactant, then it has a unit according to the chemical reaction. And if the concentration of reactant is greater than the concentration of product, again it has the unit according to the chemical reaction. So we know that Kc is the ratio of the product over the concentration of a reactant, so it has no unit. However, it depends upon the activity of a reaction. Now, equilibrium constant expression does not depend upon the amount of concentration, it depends upon the temperature. If we increase the temperature or decrease the temperature, it will affect the value of equilibrium. This is the end of equilibrium constant and its unit. Now with the help of an example, you can calculate the value of equilibrium constant. For example, H2 hydrogen molecule react with iodine, it forms hydrogen iodide. In equilibrium mixture, the concentration of hydrogen and iodine is 0.04 moles per decimeter cube, while that of hydrogen iodide is 0.08 moles per decimeter cube. Now find the value of Kc. For this, we express it in equilibrium constant expression. Hydrogen iodide, molar concentration of hydrogen, molar concentration of iodine. Now put the values. Hydrogen iodide 0.08, hydrogen 0.04, 0.04. If we calculate it, then the value equal to 4. So if we know the concentration of a reactant substances, we can find out the equilibrium constant for a chemical reaction. Thank you.